Hey, good morning guys. Kumusta na ang inyong mga araw? So, dapat ingat lagi tayo. Stay at home. So, na nakaraan, na-discuss naman natin ay yung about sequence, number sequence, finite, and infinite sequence. So now, let us discover about recursive and explicit formula. What is a recursive formula? A formula for finding the end term of a sequence is a rule of the sequence. Sometimes the sequence can be defined by stating the first term, a sub 1, and a rule that shows how to obtain the end term or any term, which is n plus 1. And it shows a sub n plus 1 from the preceding term, which is a sub n. Example of a recursive formula is write the recursive formula for the sequence of the tournament dates in a chess club. The dates are 4, 11, 18, 25. Look at the pattern. We have 4, 11, 18, 25. What is their differences? So let us subtract 11 from 4. So 11 minus 4 is 7. Another one, 18 minus 11, we have 7. 25 minus 18 is 7. So therefore, their common difference is 7. So you get from each term to the next by adding 7. So our first term is 4. So this first term will be added by 7. So 4 plus 7 equals 11. So our second term is 11. So therefore, we will add it by 7 again. So 11 plus 7 equals 18. Our third term will be added again by 7. So 18 plus 7 equals 25. So we have the term of a sub n plus 1 equals a sub n plus 7. So the preceding sequence is always added by 7. So our recursive formula is a sub 1, or the first term is 4, and any preceding term is equal to a sub n plus 7, which is for n is an element such that 1, 2, 3, 4. Another example of recursive formula. Write a recursive formula for the sequence 1, 2, 4, 8, so on and so forth, and find the next 3 terms. Look for a pattern, or look our pattern. 1, 2, 4, 8. So is there a common differences? Or common difference? 1, 2, 4, 8. So as you can see, the first term is multiplied by 2. The second term is multiply again by 2. Then the third term is multiply again by 2. Because when we divide the succeeding sequence, all of them are divisible by 2, whereas 1 is our first term and our second term is 2, and our third term is 4, and our fourth term is 8. Therefore, we have 2 times 1 equals 2, 2 times 2 equals 4, and 2 times 4 equals 8. So for every preceding term or sequence, we have the equation of 2 times a sub n. Recursive formula, we have a sub 1, or the first term equals 1, and the preceding term equals 2 times a sub n. So to find the next 3 terms, we substitute in the formula to find the 5th term, 6th term, and the 7th term. So 2 times 8, which is 8, is our 4th term. So therefore our 5th term is 16, and 16 is multiplied by 2, we have 32, and 32 is our 6th term. And 32, multiply it again by 2, so we have the product of 64, and 64 is our 7th term. So therefore our next 3 terms in this given example, we have 16, 32, and 64. How about the explicit formula? It designates the n term of the sequences as an expression of n, where n the term's location. It defines the sequence as a formula in terms of n. It may be written in either subscript notation, a sub n, or in a functional notation, which is the function of n. Example number 1. Sequence such as 10, 15, 20, 25, 30, and 35, so on and so forth. As you can see, our pattern is added by 5. Now the first term, which is 10, second term 15, third term 20, fourth term 25, fifth term 30, and sixth term is 35, so on and so forth. We have the subscription notation. We have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, so on and so forth, a sub n. And function notation, function of 1, function of 2, f of 3, f of 4, f of 5, so on and so forth, f of n. Our recursive formula, we have a sub n equals 5 times n, because for every term number, we multiply it by 5 and added by 5. Therefore, our function notation is equal to 5n plus 5. So, from the given, we can factor by 5 times n plus 1. For the explicit formula, from the given recursive formula, we have the function of n, which is reverse of the first term, plus 5 times n minus 1. Next, to summarize about the explicit formula, first, determine if the sequence is arithmetic. If it is not, so therefore it is geometric. Do you add or subtract the same amount from one term to the next? Then second, find the common difference, the number you add or subtract. Third, create an explicit formula using the pattern of the first term added to the product of the common difference and one less than the term number. So, pwede naman din dito yung geometric sa explicit formula. Pwede din naman yung Fibonacci sequence. So, take a look at our second example. Our second example, the sequence such as 3, 6, 12, 24, 48, 96, so on and so forth. Find an explicit formula. So, as you can see, it is not an arithmetic sequence. It is a geometric sequence because they have a common ratio, which is 2. Because 3, 6, 12, 24, 48, 96. So as you can see, the numbers succeeding is multiplied by 2. So 3 times 2 is 6, 6 times 2, 12, 12 times 2, 24, 24 times 2, 48, 48 times 2 is 96, so on and so forth. So let us find out the explicit formula. So as you can see, our pattern is 3, 6, 12, 24, 48, 96, and so on and so forth. And we say that the succeeding sequence is multiplied by 2. So notice that this sequence has an exponential appearance. So also, we can adopt the exponential. In subscription notation, we have a sub n equals 3 quantity of 2 because all the terms or succeeding terms are multiplied by 2. And we find out that we can use the exponent to multiply by 3. So when we have the second term, the n is 2 minus 1, we have 1. So 2 raised to the first power is 2, 2 times 3 is 6. If we have the third term, should be 12, so 3 minus 1, 2. So 2 raised to the second power is 4, 4 times 3 is 12. Another, if we have fourth term, so 4 minus 1 is 3, 2 raised to the third power is 8, 8 times 3 is 24. So it is the subscription notation. In function notation, we have f of n equals 3 quantity of 2 raised to the n minus 1. And our explicit formula from that given is 3 times 2 raised to the n minus 1, or 3 quantity of 2 raised to the n minus 1. Next, we have the practice. So practice pa more. So kindly get your notebook or paper and ball pen or pencil to write your answers, or give also the solution how you come up with your answers. So the question number 1, given the sequence 25, 21, 17, 13, so on and so forth, write the explicit equation that models the sequence. So we have the given choices. Second question, write the explicit formula for the sequence -4, -6, -8, -10, so on and so forth. Next, we have for third, what is the common ratio for the sequence 3, 15, 75? Next, fourth question, what is the explicit rule for the sequence 11, 22, 44, 88? Next, fifth question, what is the first term or a sub 1? 3, 15, 75, 375, and 1875, so on and so forth. Another question, given the sequence 4, 11, 18, 25, so on and so forth, what is the third term? Next, given the recursive formula, find the first 4 terms. So we have the recursive formula of a sub n equals a sub n minus 1 plus 5. Our first term is equal to -16. So find the first 4 terms. Next, write the recursive rule for the sequence 17, 1, -15, -31, so on and so forth. So we have the choices. So kindly show your solution. Next, nothing follows. So for this day, I'm hoping that you learn again from another topic, what is recursive and explicit formula. You may visit our Google Classroom for those who are online, and for those who are in modular modality, you may read our illustrations and example about recursive and explicit formula. Thank you for your listening. Good luck and have a nice day. Thank you.